Welcome back, Calcsters. Good news and bad news. Good news, it's past the drop day. I had a whole joke planned out that I just didn't have time to commit to this morning. That was not really a threat. Like, good on you guys. We're going to get through it. We're going to kill it. 5s is what we're after. All right, so 5 is the best you can get on the AP test, just so you know. Sweet. Oh, man, I forgot how to do everything. Help. My calculator's over there, so if I have to go get it, I will. But help. Oh, hey, we have a function right here, and I know how to find the rate of change. Oh, okay. How do you find the average rate of change again? Gosh, I'm just so forgetful. I'm okay with that. Can you make it more functiony? Like f of something, I think. It is b and a, but what are b and a on this one? Sure, f of 5 minus what? F of negative 3 divided by what? Divided by 5 minus a negative 3, which is plus the positive. Cool. I'm pretty much done. I'm just going to do a little calculating, right? What's 5 squared? Minus 9. 16 minus, what's negative 3 squared? Minus 9? Okay. Over what's 5 plus 3? All right. I have 16 over 8. Could I keep it here? You could. I will not count you wrong if you keep it here. In fact, I would encourage you, it goes against my personal preference, I would encourage you, don't go any further than this. Because all it takes to go from getting this problem completely right to missing points on this problem is to do something silly that naturally happens. This is an easy mistake to make. Somebody will do it inevitably. I don't think I saw anybody do it here today, but it will happen. Like, you just get goofed up. You've gone from being completely right to completely wrong. You can stop here. I'm going to put the bullet point at 16 over 8. I really wouldn't stop here because it bugs me. What is it? And we done. Okay. Any mistakes that you've made and identified throughout that process, please share. What did you do wrong?
I just plugged it, like, I kept the, like, x, but I didn't turn it into, like, I put it into an equation, but I kept the equal sign. I did not turn it into a fraction, and, yeah, I basically, like, ruined the whole problem at the start.
So that'll happen. That's okay. Are you cool with what we did do for this problem?
Yeah, I understand.
Okay, awesome. We have one more awesome one that I remember you guys loved from pre-calc. So good news is you've seen these before. Realistically, whether you remember it or not, I don't know. But we're going to do one more average rate of change. We're going to try to make sense of this. So I want to make sure I get this wonderful, easy example for us. What are we doing Friday? Somebody remind me? On what? We're quizzing limit properties. The limit of a quotient is what? Okay, easy. Deal. All right. We're not in 1.4. We're not in 1.3. Oh, man. We're going to do one more example. And if we need to do it together, we will. It's going to look awful. It's not really awful. It's just going to look awful. So this example, I'm going to put a vocab just in the part of it because it's been a while. Anybody remember talking last year about something called a difference quotient? Okay, I'll look here. I don't know why I'm looking up there. Okay, you might not recall. Now, I don't want to just reveal all of the secrets of calculus to you at this point in time, but when you see the word difference, difference means what? Subtract. And then quotient means you're doing what? Dividing. Okay, so we have differences that are being divided. I'll go back to that in just a second. I just want to look at something. We had differences that we're dividing. We've been doing kind of what's called a difference quotient. We're going to do much more generalized right here. Okay, this is nothing new. The format is going to look a little bit different, but let's get through one together. So, difference quotients, just so that we have it. Definition-wise, it is this guy. F of x plus h minus f of x, all divided by, and if I wanted to do this out like it were the average rate of change, or just any rate of change, it would be x plus h minus x, right? That's what would have to correspond in the denominator. If we did x plus h minus x, it'd just be left with h. Okay. As soon as we write this here, those of you that I had in class last year, do you recall doing these? It was a very, very little part of chapter 1 at the very end. Difference quotients for just a moment. If you don't recall, that's okay. Now, we can go this two ways. This is going to become a fundamental idea for us throughout the study of calculus and derivatives specifically. Do you want to see the graphical reason that we care about this right now, or do you just want to practice with our limit properties? What do you want, Riley? Do you want to see what this actually is, or do you just want to do the limit of it? Good. That's what I was hoping. Not really good. I would have said good the other way too, just for the record. Check it out. These things, super easy to think about. We don't have to be real big. Average rate of change is just between 2 points, right? Like, literally, that's how we find it. It's a slope between 2 points. So here we go. I'm going to draw a function that does something like this. And I'm going to make it curvier. There we go. Now, I could pick some x value, I think. I'm going to do that. I'm going to pick right here. Check it out. There's x. I'm going to make it look nicer because I don't like that. There's x, which means if this function is named f, this ordered pair has a coordinate x comma what? Louder? Okay, f of x. Okay, whatever value that is, we just plugged in. Now, when we want to find an average rate of change, which if I hadn't said the word difference quotient, I could put another point here, right, and say find the difference, or find the average rate of change. I'm going to go some distance over, and I'm just going to call this, I don't know, h is how far I'm going to the right. Some horizontal distance. I don't know what it is yet. Everybody still on board? Okay, so if I say here's the distance h, this point, would you agree then, must be x plus h? Checking for little looks on your faces so we can see if this clicks. I have x, I move over h, I'm now at x plus h. What's the corresponding y value up here? F of x plus h, right? Now, if I asked you to find the average rate of change between these, we just find the slope of it, yeah? Now, here's what I want you guys to help me make sense of. We're going to let a function f of x be very specifically defined, and then I want to think back to this and see what does it really do when we take its limit. Or we can do it now. If I were to take the limit of this difference quotient, so I'm going to do this in a different color. This is not our main idea, but this is a pretty big motivator for the rest of the semester. If I wanted to take the limit as h approaches 0 of this, what I want to know is what would we actually be doing on this graph? Now, there are a few different ways to think of it, but I want you guys to discuss, play around with it. You can draw on your graph, right? Like we're going to see this graph again, I promise. What did we actually do when we let the distance h go to 0? Cool. I want you to think about it, talk it out for a minute. What does it change about my graph? If you need to add another point, we could, or more points, we could. 60 seconds, really vague question. What are we actually doing here? Go, talk. Bigger question, maybe. We can find the slope, right? That's what I meant. Like the difference quotients and stuff is the slope. Like that's very slow. If I let the distance between these points go really close together, I still have I can do the average slope here and here and here. But as h gets arbitrarily close to 0, like if h gets to be as small as we possibly want, you couldn't even distinguish between x and x plus h, right? But there'd still be 2 points there. They're just so close together you can't see it. If you have 2 points, you can find the slope. So let's think about this. Okay, so you guys, I spoke with these people, and you people spoke. What's it doing? The same, what do you mean?
Like x plus h is going to be equal to x, or f of x plus h is equal to f of x.
Oh, I love it. So h gets closer and closer, right? You will not have the ability to draw this as nicely as I can because I have technology. Here's our first line, roughly. Like the slope of that is if we just did the difference, okay. We're gonna pretend it's perfect. That's the difference quotient, right? Now, if I let h go to 0, and you don't have to add more to your picture, but eventually, like maybe it'd be here. That's closer to 0, right? So I still have the slope of a secant line right here, but the slope has gone down. It's less steep. I'm going to clear this each time so it doesn't get too muddled. Eventually, what Fern just said is that point is going to get so close that they're essentially the same point, right? So it would mean for all intents and purposes, I now have a line that touches it instead of at 2 points. It's essentially how many points? 1, not infinitely, because if I have this point here and this point here, eventually if the distance between them gets so small that it's not even noticeable, it's almost like you have 1 point, right? But you can't really find a slope of 1 point. We have to do 2 of them. This right here is a fundamental idea that we'll talk about a lot. This gives us the slope of not the secant line, which touches twice. This gives the slope of the what line, Sean? The tangent line. Not tangent, weird. Tangent line at x. Okay. I think a couple of people in here have seen a little bit of calculus. Can anybody tell me what this is? There's a word for this. We won't write it down right now, but there is a really important word for this. It's a derivative. Why do you know that? Baller. Good for remembering it. Cool. This is a derivative. There are a lot of really easy shortcuts, but it turns out, hey, it's just a limit, which is what we're focusing on here. So here we go. I want to do a limit of a difference quotient, and let's just see what it is. So on A, we'll do 1 together, and then I'll give you guys a bunch of time to work through stuff. Do we want to do this one? We'll do an easier one. I want f of x equals x squared plus 1. I want us to evaluate the limit of the difference quotient. So I'm going to help us set this up. A little bit of scratch work is always a good idea, especially, just no especially, just always. Okay, if I want to do the difference quotient, I already know what f of x is. Here it is. It's easy. What else do I need in this formula? F of what? F of x plus h. So we're not going to freshman dream right now, and I'm going to scoot this. Oh, I can just slide over. I want to figure out f of x plus h. It literally means in this function, anywhere that there's an x, what do we replace it with? X plus h. We're just evaluating it for this new value. So let's try that. I'll set it up, and I want you guys to algebra. So it becomes x plus h squared plus 1. Does everybody in here know how to FOIL? If you can multiply this by hand, do you think it's really necessary for us to practice that by hand right now? What might you do instead? You can expand using the algebra tool on your lovely TI-89 calculator. If you want the practice, or if you think you can't do this by hand, you should try it by hand. I'll do it by hand. I want you guys to expand on your calculator. So here's the issue that I had with the first one I tried. I did get the batteries to work, but it won't turn off or on. So you'll use mine for today, okay? Where do I find expand on this lovely calculator? So we go on, and you hit the home button to get to the screens. Up top on F2, there's an algebra tab. Hit it. Give me some options. I don't remember the order they come in. Solve, factor, expand. You are expanding this thing. Now, because we're not solving or telling it to do anything, any particular variable other than x, I don't think we need a comma x at the end, but you guys will know that here in just a second. Notice it starts with a left parenthesis. When you hit expand, you have to end with that right parenthesis, maybe 2 of them at the end once you're done. There will only be 1 in this one, actually. But I'll give you a second. You might have already expanded just with that. Yep, I'll go to that. And I need you guys, I'll help you in a second. Verify for me. We get x squared plus 2xh plus h squared plus 1. So, good question. So, check it out. We have, so on this, a couple anytime that we have this, I'm not going to put the next parenthesis, I'm going to wait. So we need to square x plus y, and I'm fine with that. You can use y, that's fine. Let's do x plus y in parentheses, because if we were to do this by hand, it would have to be in parentheses. And for a square, it's this caret. Yep, and squared. Nope, you just have to, so we'll escape. So 2, because it's already up there, so it's squared. And then what's outside of it? Plus what? Okay. Now, notice right parentheses needed. We have 2 left and 1 right. We have to end with a right parenthesis. So right parenthesis, let's see what we get. Boom. And we get the exact same thing. Okay, everybody get this in your calculator. Cool. Terrible way to ask that question. Anybody not get this in your calculator? Okie dokie. So let's run with it. We have f of x plus h. Let's evaluate out a difference quotient. So we're actually going to do the limit of the difference quotient. Let's do the limit as what distance is going to go to 0? H. The limit as h goes to 0. Now, I could write this whole thing again. I think it's redundant because it's already on the board for us. So let's just see. Here's f of x plus h. I'll do it in green. The numerator is f of x plus h, x squared plus 2xh plus h squared plus 1. That's f of x plus h. Okay, I'm going to make a mistake very intentionally. I want you to tell me my mistake. What do we subtract from this?
X squared plus 1.
Okay. And that's all over h, yeah? Okay. I want you to think individually for a minute. I'm going to give you like 10 seconds. I've made a mistake. Where? What's my mistake? 10 seconds. Don't shout it out. You are then going to turn and talk with your neighbor and see if you guys identified the same mistake. So what is the mistake that I have on the board? Turn and talk. Meow. What? Why would parentheses break it? That was fast. Did everybody see parentheses were missing? Does it change anything? What's it change? Minus x squared minus 1 is what will shake out. Instead of doing a whole nother line with the parenthesis, I lied, I can copy and paste. If I were you, I would just change this plus sign to a what? To a negative. But I'm going to copy and paste so that I can show it all. It is up to you if you want to be super tedious. Have we taken a limit yet? No, so the limit symbol still has to be there. Okay, I'm going to just distribute this through. Too big. Do the parentheses around the f of x plus h really matter? Are they doing anything? Is there anything to multiply by, a negative or another constant? I'm not going to erase them. Do we need them though? Nope, they're cool. All right. Sweet. So now what should I do? So yeah, let's try direct sub. Uh-oh, I divide by 0. Bummer. So just to be clear, because that might not, like, the second that I know that there's an h in the denominator, I know that this thing's broken. If I don't want to have to deal with it, can we try to clean it up a little bit? Clean up the argument of our limit. Just show me, is there a nicer way that we can write everything that we're actually taking the limit of? Any simplification that's clean and nice and easy and obvious. That's your first step. I'm going to give you like a 5-second head start. Clean it up. Cancel out any like terms, combine, all that good stuff. I think you worked all the way through. Fantastic. What falls out? Okay, so when I actually do this, and I'm okay if you guys do this, I need really clean and detailed organized work, right? Because especially on the free response questions, we haven't talked at all about the AP stuff, but there's 9 points on each question. And like the grading guides, the scoring guides, they're very specific. The student shows that they have done this limit and this was the argument. Like that sort of stuff is in there. You have to show really clean work to get full credit on the AP test. So here we go. This is sufficient. X squared and x squared. Anything else? 1 and 1. Now, on my next line, I could write everything that remains, and you could, and I actually will, because again, that whole copy and paste thing. This is all that's left upstairs, yeah? So I've simplified a little bit. I mean, not really. We just cleaned it up. Could I try direct sub again? I mean, I can try, but I still get 0 over 0. Shucks. What do we do? We should always think about if direct sub fails, my first stop is always, I'm going to factor if I can, and I try to divide stuff out. If that doesn't work, I might try either the rationalized stuff or factor a goofy thing like we saw yesterday, right? However you think about it, we get the same result. What comes out of the numerator? H. When I take an h out of the numerator, what remains in the numerator? 2x plus h, and that's still all divided by h. At this point, they're gone. They have now divided out. Do I worry at all about dividing by 0 anymore? Nope, we cool. Well, I'm cool. You guys are okay. Have we done the limit yet? No, notice, I still have the sign. If I do the limit, what happens? If h goes to 0, what changes about 2x? Nothing, okay? If h goes to 0, what happens to plus h? So I wouldn't normally write it, but do you guys agree that it's plus 0? Which means we just found that the limit of this is 2x, right? Here is the power of this. If I wanted to know, and there's so many different applications of this, but there's lots of stuff that gets modeled with x squared plus 1, whatever, parabolas are really common. If I wanted to know how fast is my parabola changing at any x value, for example, when x equals 5, if I were to get x squared plus 1, and I'm just going to do it really sloppily. You don't have to draw, this is just me talking. I hate the first one. If I have x squared plus 1, here it is. And I want to know the slope when x is 2. At this tangent line, it would be about like this, yeah? What do you think its slope is? Why 4? You're absolutely right. This tells me that at this point in time, it's changing at 4 units per whatever, units per time. When x is 5 later, does it change faster up here? Is my slope bigger up here? What is the slope up here if I'm at x equals 5? 10. Oh, my derivative. It gives me all this information about any place that it would want to know. Now, we won't do it, but turns out there's crazy information on this. If and we're just going to take a little quick glance ahead at what's coming up and why we care. That function is not terrible. Is this function as nice? No, not really, right? But if I ask for, hey, are there any maximums or minimums? Could you tell me the slope at here or here or here or here if I tried to do what I just did? What's the slope going to be right here? At that tangent. So I'll even do it better. Go with your gut. There's not like a formal answer. What do you think the slope of that line is? Oh my gosh, what about the slope of that line? And that one? And that one? Holy cow, we now will have a way to find all the mins and maxes of a function by doing very little work. You don't even have to graph it. We can make sense of it all without ever dealing with the graph. This is the very beginning of derivatives. I'm so excited. I almost have goosebumps. Not quite, but we're almost there. Okay, feeling all right with stuff. Cool. You get some time to do an assignment. So let's see here. We haven't had any 1.2 homework, have we? Okay. So check it out. We get a lot of time in class today, which means as long as you're working, I have no issue with it. We'll go to Calc. What? Weird. All right, tonight you will get homework 1.2. And I'll go all the way down here. Homework 1.2. Okay. Heads up. I did not give you guys homework last night, so this is like 2 assignments shoved together. If we need more time, I'm cool with that. How long did you spend out of class? 45. Let's commit to 45. I'm good with that. Maximum outside of class. Cool. You guys have 20 minutes in class, so we should be able to get pretty close. Homework 1.2 will begin on page 100, I think. I want you to do 35 through 47 odd, 48, 55, 59, 63, 67, 73, 77, and 79. Okay, again, I know it seems like a lot. I don't think it'll be terrible. We'll see. If I have to adjust at the end of the hour, I will. But for now, this is what I would like to do. I've shortened both parts of this. 35 through 47 odd, 48, 55, 59, 63, 67, 73, 77, and 79. Cool. Yes, I was actually Googling them this morning. I know I have some. I'm gonna find them and I'll print them. Cool. Save. Thank you. Oh, no, yeah. No. Like, I can give you a note card, but you can't use it on a quiz. Yeah, yeah, absolutely. Like, you're gonna make your own flashcards is what you're saying? All right, we're gonna back up. I have note cards, yes. What would you like to use the note cards for?
For the quiz on Friday.
So, like to study for the quiz on Friday?
Yeah.
Yes. Are you gonna make flashcards out of them?
Yes.
Like that's what you're
Like
gonna
that.
do? Okay, yes. I'm gonna just try to find you something to print so you don't have to spend all the time making them.
Okay.
Yeah. Yep. Heads up, there is no note cards on any quiz or test in here. We'll get through it. We'll get through it. You don't get on the AP test. Because of that, your retakes might feel more valuable than other, like maybe just taking